We're going to use async twice. Once to push some code to a background thread, then once more to push code back to the main thread. This allows us to do any heavy lifting away from the UI where we don't block things, but then update the UI safely on the main thread, which is the only place it can be safely updated. How you call async informs the system where you want the code to run. GCD works with a system of queues, which are much like real-world queues. They are first in, first out, or FIFO blocks of code. What this means is that your GCD calls don't create threads to run in, they just get assigned to one of the existing threads for GCD to manage. GCD creates a number of queues for you and places tasks in those queues depending on how important you say they are, meaning that each block of code will be taken off the queue in the order they were put in. But more than one code block can be executed at the same time, so the finish order isn't guaranteed. How important some code is depends on something called quality of service, or QoS, which decides what level of service this code should be given. Obviously at the top of this thing is the main queue, which runs on your main thread, and should be used to schedule any work that must update the UI immediately, even when that means blocking your program from doing anything else. But there are 4 background queues you can use, each of which has their own quality of service or QoS level set. There's user interactive, which is the highest priority background thread, and should be used when you want a background thread to do work that's important to keep your UI working. This priority will ask the system to dedicate nearly all available CPU time to you to get the job done as quickly as possible. Then there's user initiated. This should be used to execute threads requested by the user that they're now waiting for in order to continue using your app. It's not as important as user interactive work, i.e. if the user taps on the buttons to do other stuff, that should be done first. But it's important because you're keeping the user waiting. Next is the utility queue. This should be used for long-running tasks the user is aware of, but not necessarily desperate for now. If the user has requested something and can happily leave it running while they do something else with your app, you should use utility. For example, processing lots of photos. Then there's the background queue. This is for long-running tasks the user isn't actively aware of, or at least doesn't care about its progress or when it completes. Those quality of service queues, or QoS queues, affect the way the system prioritizes your work. User interactive and user initiated tasks will be executed as quickly as possible regardless of their effect on battery life. Utility tasks will be executed with a view to keep power efficiency as high as possible without sacrificing too much performance, whereas background tasks will be executed with power efficiency as its priority. GCD automatically balances work so that higher priority queues are given more time than lower priority queues, even if that means temporarily delaying a background task because a user interactive task just came in. There's also one more option, which is the default queue. This is prioritized between user initiated and utility, and it's a good general purpose choice when you're learning. Enough talking, time for some action. We're going to use async to make all our loading code run in the background queue with default quality of service. To do that, we'll go up to here before the if-let call and write dispatch queue dot global with a quality of service of dot user initiated dot async. And inside here is our code. Now this thing here, this is now a closure. All this code here is a closure that's being passed off to the dispatch queue system, that's GCD. As a result, we've got to be really careful how we use this code. First, we need closure capturing. We've got to make it clear how we're capturing self in here, because you can see it's calling parse down here, and that's an implicit capture of self, because it really means self.parse, the JSON data. So we've got to decide how we're capturing self. In this case, using weak self is a good idea. So I'm going to write up here inside the closure, our closure capture list is going to be brackets weak self in. With that change, we can now use self weakly inside there to clarify how the parse method should be called. So we can write, instead of just parse JSON data, we can say self ? dot parse JSON data. And that's all it takes to parse all our work on a background thread. The UI will no longer freeze while it's fetching the data. If you want to try the other quality of service queues, go ahead and replace user initiated with a dot and see what else you get. You can see user interactive or utility right there to try out.